Good day, I'm Martin Gagel with Market Radius Research. It's Wednesday, March the 23rd, and we've got CEO Ronald Glibbery and CFO Jim Sullivan of Peraso joining us. Peraso develops 5G millimeter wave wireless chipsets, modules, software, and IP for the fixed wireless, immersive video, factory automation, and other high bandwidth and low latency applications. I've got Peraso on today because I am very interested in them as they were introduced to me by some of their early stage investors, a VC group that I have great respect for. I'm very interested in learning about the 5G space as well, especially the millimeter wave part of the technology. I believe there's a lot of misunderstanding of what 5G is and confusion about the variants, which I'm sure we'll clarify on the call. Also, I'm hoping we'll better understand the hype around 5G and its implications for next generation technologies like the metaverse, industrial automation, and autonomous vehicles. But please remember, this is neither a recommendation nor investment advice. We're here to learn about the company. Ron, Jim, thank you very much for joining us, and please tell us about Peraso.
Well, thank you very much, Martin. Pleasure to be here, and appreciate the time that providing for us today. Just before we move on, I just want to let people know that we've got a safe harbor and forward-looking statements. So please make sure you're aware of those before we proceed. And this is in a standard presentation. So thank you for the introduction. Peraso, as Martin mentioned, we're a semiconductor company. We make chips for a living, and we're focused on a market called millimeter wave, which is a very high frequency wireless technology. The company was founded in 2008, so we have a lot of experience, and as I'll explain in subsequent slides, millimeter wave is a very challenging technology that does take many years of experience to get right. However, we are a company that's in production. We are shipping. We have existing tier one customers, and we would consider ourselves the leader, or certainly one of the leaders in the world for millimeter wave technology. And I think the really important concept that we want to get across today on millimeter wave is that, it really does incorporate, besides, the semiconductor technology, several elements of the system, including, antenna technology, which we've developed, substrate technology, significant software. So it's really a system that we've really put together as a company, and what really puts us in the lead in terms of being a leading provider of millimeter wave in the marketplace. So the next slide I'm going to show you is actually, this speaks to Martin's point earlier. And so you can see that really this, in my opinion, is really the thesis that's driving the need for millimeter wave. So just to clarify, excuse me, I have a bit of a frog in my throat. Millimeter wave really refers to, in 5G, typically in 4G, there was all of the spectrum was below 6 gigahertz, but a significant change in 5G was at the ITU actually allocated spectrum in the millimeter wave band, and that is really from about 24 to 100 gigahertz. And the reason for that is the 6 gigahertz band and below is simply running out of gas. And I think this slide is a very, very important slide and something to keep in mind throughout the presentation. And if you look at this and you look at the red line, that's really the demand within a 5G network, particularly in the US, but really I think you can apply this globally. And the idea is that demand is growing exponentially. That's a fact. And I think that we've got data to support that. And we believe there's a couple of factors. I mean, certainly there's more users on the network, but the other word I would use to describe that demand or the growth in demand is video. And anybody that has kids on the call, I know I do, 90% of their use on their phones is TikTok. And in fact, it's become such a prevalent part of their day-to-day use on the phones. Even companies like Facebook now are reacting with things like Facebook Reels, which is competitive to TikTok. So we're really seeing, of course, Netflix, sporting events, even upload applications like Twitch, where it's just a very, very high demand for video. So between new users and this massive migration to video, we see that the demand is increasing. The problem for the carriers is that in sub-6, they're simply running out of bandwidth. I mean, they're trying, and you can see that the recent introduction of the mid-band spectrum is helping, but it's really just a matter of time before what I would call that, prime beachfront property is going to be used up, and the network operators will be forced to move over to the millimeter wave band, and that's where we come in. Actually, I thought it was quite interesting, even over the last couple of weeks. There's even a 6G, if you can believe that, generation come along, and most of the proposals are using even more advanced than millimeter wave. So clearly, organizations around the world are recognizing that we're running out of spectrum below 6 gigahertz, and millimeter wave and above is where the network carriers have to go to really satisfy the demand, this increasing demand for more users and the move to more robust data applications. So that's really the thesis.
So Ron, when we in 4G in the in the spectrum here, it only went up to the 6 gigahertz, and beyond 6 gigahertz just wasn't part of the 4G capabilities. Is that right?
Correct. Yes.
And then the more of spectrum we have, like you can only fit so much information, no matter how many cell towers you have around you. If everyone's downloading or uploading Twitch videos and doing that, it just gets congested. So there's no more bandwidth within that spectrum. So the more spectrum you take, then the more data can get pushed through the entire the airwaves.
Exactly, right? And that's exactly what's happening. I mean, it certainly has a nice amount of spectrum below 6G, but it's just the more people that are on it. And like we can take an example of Facebook Reels. I mean, that's why I put it here. Actually, if you think about it, a Facebook page has a certain amount of information on it, and you historically used to look at that Facebook page and use so much bandwidth. Now you've got a video playing that takes at least 30 times the bandwidth. So it's just really an exponential increase going from like static web pages to video-based information. So that's definitely part of the issue that we're seeing. Not to mention there's a lot more users. Even things like moving to higher resolution video, 4K or 8K, eventually just really saturates that bandwidth, if you will, below 6 gigahertz, and why we're seeing that demand now, and the need for the network operators to eventually move to millimeter wave.
And currently with the 5G iPhone that I've got, and most of us either have or are transitioning to, that is on your spectrum side, the red part that people are, that's the common use area right now, below 24 gigahertz. And is that sort of the spectrum that's being used commonly now for the 5G?
Yeah. So you actually, it's a good question. I think it's a good thing to clarify. I mean, I think when the carriers were promoting 5G, if you will, all you heard about was 10 times the speed and 1/10 the latency. Well, that's actually true if you use millimeter wave, actually.
Yeah.
So really, as it turns out, 5G generally today is just replacing 4G, and that's why most users really don't see a difference. And a lot of people are saying, well, what's this 5G stuff? I mean, I'm not getting, nothing's really changed. Where people are really going to see those changes are once you start using the millimeter wave bands. It really does provide 10 times the bandwidth and 1/10 the latency. And so that's the real benefit of the millimeter wave technology.
On my phone, I've got an iPhone 12, or I forget the numbers now, but do they all have ability to go to the 100 gigahertz, or are some 5G like antennas and so forth only designed to go up to 24 gigahertz, and then other devices are ones that use the higher frequencies?
Okay, so Martin, in 5G, there's actually two frequencies specifically that are fine for millimeter wave: 28 gigahertz and 39 gigahertz. Okay. So those are the bands that are being used for 5G. Yeah. So millimeter wave is just defined as that full band, but the bands that they're actually specifically using in 5G are 28 gigahertz and 39 gigahertz.
Gotcha. Yeah. And our phones are typically 5G phones. Do they have that millimeter wavelength capacity built into them, or is that sort of, will that be like 5G plus for people on cell phones?
In the US, all of the iPhone 12s and all of the iPhone 13s have that capability. Yes.
Okay. Yeah. Gotcha. And one in it is when you get to the millimeter band wavelengths, Are those ones, is that where they have trouble penetrating walls, and that's somehow where if you're standing right next to the cell tower, you get to use it, it's awesome, but once you go around the block, you kind of switch back to the more the 4G replacement 5G, the non-spectacular 5G, so to speak?
Right. That's true. That's the early stages of millimeter wave. It does require more coverage, if you will.
Yeah.
So I think, and I'm quite sure now what the carriers have decided, and what you're seeing as kind of the first wave of millimeter wave is really congested areas. So like at the Super Bowl or the Indianapolis 500 or rock concerts or any forum where you've got tens of thousands of people, and I know I've been there myself, where you think you get a signal, but you can't get on the network. It's just because it's bogged down. Millimeter wave totally changes that. So it's actually quite interesting, because I think for the carriers, as opposed to complete broad coverage across the US, so everywhere you go, you've got millimeter wave, they're going to put it in the areas where there's high congestion as a starting point. Okay. And so that way, if I'm a customer of Verizon, and I, 10% or 20% of the time I'm in a location where there is that high congestion, I'm going to get a signal. And that's a real high value add for the carriers. And if they don't have it, really, it's a likely source of churn for those guys, because it's like, well, this carrier, when I go to those situations, will support me, right? And that's how you're going to start to see the rollout of millimeter wave. We've already seen it. I think another great example is airports, for example. So AT&T is rolling out millimeter wave to airports. It's really quite a, first of all, you've got very high congestion in airports. Second of all, if I want to get on a plane and I want to download 2 or 3 movies, now I can do it in 15, 20 seconds. Boom, I've got my movies downloaded. I get on the network in the first place, was the first challenge. Now I'm on the network. It's so fast. I can download those movies pretty instantaneously. Boom, I'm on the plane. So I think that you're going to start to see those initial rollouts of millimeter wave in those high congestion areas. And then over time, we'll see the broad rollout across the entire network.
And on the millimeter wave, their antennas, like you were saying, you need to place them, need to have more in an area, because they get interference from buildings or whatever. So more coverage, antenna spots within a congested area to get that coverage.
Yeah, but typically in an airport, it's more line of sight. So typically in an airport or at a stadium, with a few access points, you can cover the whole area, if you will, right? Where, you do have an issue if you've got a building blocking it, then you'd have to put a second access point and have a handoff between those 2 access points. So it would require more, base stations or access points. But if you're in an open area like an airport or a stadium, because you've got line of sight, you can see all of those people with, relatively few access points.
All right. I feel like we've kind of covered this well. Is there anything I missed, or is this
No, I think
good? Oh,
that was exactly what I was trying to get at. And I think that, the point again is that, for, traditional, 4G, 4G use case, really the initial rollout of 5G is just replacing that 4G, which is why people are saying, what's the big deal about 5G? With millimeter wave, you really will see that 10 times performance improvement and that low latency.
All right. Thank you very much.
My pleasure. All right. So just in terms of what makes Peraso special, I mean, millimeter wave is actually, because it's such high frequency, it's very finicky and very sensitive technology. So this page is really kind of a tribute to, what we've accomplished over the last 13 years from a technology perspective. First of all, from a performance perspective, we've got customers who are actually doing 30-kilometer links. I think that's the other really important message about millimeter wave, Martin, is that, I think people weren't sure if it was going to even work. Now we're seeing 30-kilometer links. It's really quite amazing. And in our particular, customer, that's about 10 times longer than their competition. So we're doing some very special stuff in terms of, I had mentioned our semiconductor technology earlier, but it's also our antenna technology. It's also our real-time algorithms and our real-time software updates. So it really is a system that has to work very well in order to achieve that kind of performance. So we have real performance advantages in the market. this is just a very tough technology. I mean, I think in terms of our experience, these are semiconductor devices. So if you make a mistake, it takes many years to really kind of fix it, because you have to go back to the factory, you have to, rebuild it, you have to retest it. So there is a large learning curve in this technology. So we feel we have a very wide moat in terms of our experience with the specific semiconductor technology. Because we're in production, we've established very strong relationships with key customers. So we've been in, for example, the fixed wireless market for several years now. And not only does that help us with our, existing products, it really gives us insight about what they want for the future. And those customer relationships are critical for Peraso. But, we're really there because we started off with a technology that works. And so now we're in the market. We've got a very, very high software component to our product. So, we've got RF technology, semiconductor technology, but we have to really keep in mind that's coupled with, hundreds of thousands of lines of software to make our products work properly. So, so that brings a lot of value and a very, again, high switching cost to our customers. And because we're shipping in volume now, we've been able to bring our costs down. So because we're established, I think that's a key message here, is that because we're established and because we've been in the market for so many years, it really gives us a leg up on any competition. And of course, in the meantime, as our competition tries to catch up, we're moving forward as well.
All right. So you're not necessarily directly about handsets. You don't put chipsets into handsets. Apple is not your direct customer. It would be like a wireless, like broadband point-to-point communications, sort of backhaul type situations, things like that.
I mean, I do get into specifics if you want to wait a couple of slides, or
okay. Why don't we get into specifics then? Okay, yeah.
Yeah, but yeah, I speak to that specifically. But the answer is I'll get into it because I'll do it in a structured manner. But ultimately we could, I mean, as a prelude to those slides, what I would say is we've architected our 5G story or solution to go in what we call end user equipment. So there's really two broad categories. There's infrastructure, and then there's end user devices. Our focus is on end user devices, and we've got an architecture that that supports those devices in it. And we're starting out with actually is point to multipoint, which is fixed wireless broadband, but goes into end user devices. Ultimately, there's nothing stopping us from scaling that into mobile devices. But I'll get into more specifics as we get to that part of the presentation.
All right, thanks. Sorry for jumping ahead there.
No, of course, it's a great question. Just a quick nod to, we've got about 40 to 50 patents. Actually, I think classic patents would be in the implementation of our silicon. So that's actually very, very important. So we've got a variety of patents in that field. We've actually really made a point, Martin, of building up a very strong antenna capability. Actually, I think it's really important to note on this presentation that, a key characteristic of millimeter wave technology compared to traditional wireless is that the antenna needs to be right beside the semiconductor device. And so we decided some time ago that we would become experts in the antenna technology as well. And now you'll see as I move on the presentation, that's given us a real advantage in the marketplace. So we've got several patents in our antenna technology. We actually have essential claim patents, which are patents in some of the millimeter wave standards. And we've got a very strong software portfolio, as I mentioned earlier.
All right.
Okay. I just want to quickly give a nod to a core competency that all millimeter wave companies had, but I think we've got a very refined version of it, which is beam forming and beam steering. And I think, again, the key point here is that, you had alluded it to earlier, but one characteristic of millimeter wave technology is that you really want to focus the antennas and the energy. So there's a technology called beam forming, as opposed to call it like a light bulb where you just shine the light everywhere. It should be like a high beam in a car where you really focus that energy to give it more distance. And so a key competency for our company is that beamforming technology. So of course, the obvious advantage of that is it gives you more distance. That's how we get our 30-kilometer length that I mentioned earlier. But we're starting to see some actually more interesting applications. For example, transportation hubs, military or security personnel, energy installations are starting to look for millimeter wave as a countermeasure to cyber attacks. So historically, for 5G or even for Wi-Fi, it was interlopers were able to sniff the signal and actually hack your network. And this is a very, very difficult challenge with millimeter wave because of the beamforming capability. So because we've got beamforming capability, and the beam is actually always moving, it makes it almost impossible to crack a wireless connection with sniffing equipment. So we're starting to see that as an application that's coming true for us. It limits interference. So I'll talk a little bit about the work we're doing in AR, VR, the metaverse. And then also along those lines, again, to take a transportation hub, covering that whole area with multiple access points is an application we're starting to see more and more of. So all of these beamforming, beam steering capabilities are really driving us into some very specific aspects of the 5G network.
I've always curious on the beam forming or steering, if whatever, I've got my device, I'm connected wirelessly through your system, and I'm in a car, I'm driving down, it'll sort of direct the beam towards me as I go away. And it's not like the antenna has a motor on it and it's shifting, it's the electronics or how you form it. And if you're attached to 10 people, the beams will direct them in 10 different ways. So it keeps sort of the energy focused on the sender receiver where it's supposed to go to. Is that what you're basically saying?
Yeah, that's exactly right. So if you remember those old videos you see of the ships with the radar spinning around,
yeah,
well, that's a mechanical version of what we do, right? So the beauty of electronics beam steering is you don't have any mechanics. It's all built into the antenna technology. So that's exactly right. That's what we do. So you're right. So if a beam is locked onto a user, as that user moves, the system will realize that the signal strength is getting reduced, and it will move the beam to track and figure out where it's got the best signal strength to always keep that beam located in the location that gives you the best link possible. So yes, it's automatic for sure. There's no mechanics involved.
And that's how it's less hackable, because if you're on the other side of the antenna, it's not just being broadcast out widely, it's just being focused towards one area. So you have to be basically in the line of sight if you want to hack it, and then that hacker would be much more obvious.
It would be much more obvious, and just the beam is so narrow, even just finding it would be very difficult in the first place. But yeah, you're exactly right. I mean, if you've got a line of sight and you have a beam, you obviously would see the interloper, right? It's almost impossible to get into that view. So the countermeasure for cybersecurity is a real benefit.
Okay. Does 4G currently have any sort of beam forming aspects to it, or is that sort of more broad?
Not like this. They have broader beam forming, but it's much broader. It's a kind of a different type of beam forming.
Okay, thank you.
So this slide is actually quite critical to our business, and actually I think I mentioned earlier that millimeter wave is a very finicky technology. And what we decided to do over the course of the last year is take our semiconductor products and actually incorporate these onto a finished module. And what we found was, this provided the company many benefits. So for example, as I mentioned earlier, if you look at the yellow box on this slide, if you look quite carefully, you can see a little antenna pattern in there. So that antenna is built right into the PCB. And we developed that technology. And what that allows us to do is that antenna has to be very close to the semiconductor device. And historically, we relied on our customer to actually make sure that interface worked properly. But that took a long time. And it could take years for that customer to get into production. Now, we've actually solved that problem for the customer. So what we sell is a module that is guaranteed to work with a specific level of performance. So this was actually a very, very important development for Peraso. And if you look at the stack on the right-hand side of this slide, we control all of that intellectual property. And what that allows us to do is come into the market at a very, very aggressive price point with excellent, with excellent performance. And this took a long time to develop, and really is one of the key benefits that Peraso does bring to the market now is this integrated solution. We literally have gone from an 18 to 24 month design cycle to a 6 to 9 month design cycle. So it helps our cash flow, obviously, saves our customers, thousands of man hours of engineering time, and gets them into market much quicker than they normally would be. And typically in this market, third parties, for example, might add the antenna, but because we've got that antenna technology, we can provide a completely integrated solution.
And there's no blaming the other guy. Oh, it's not working. It's the antenna guy's fault. The antenna guy says, hey, it's the silicone guy's fault. It's all like one throat to choke, as they say.
One throat to choke. It's our throat, and actually the other actor in that whole process is the manufacturer. Because they could both go to the manufacturer and say, well, you didn't build this thing right. So there's a lot of finger pointing that goes away. So this looks like a black box basically to our customers now, and they love it. So even from a cost perspective, I mean, their overall system, we benefit from it and they benefit from it. So it's a real win-win. This was a tricky thing to do, to get right. And again, the real challenge with millimeter wave is that, any little mistake can cause the system to not work properly. So making sure that all of this works in harmony is something that took years to really perfect for us.
One of my assumptions, or something I think I know, is that people maybe don't quite understand this so much, antenna technology is super high tech, super complex. That's one of the areas where actually North American technology is one of the barriers to, let's say, that that's with the Chinese technology, where on the antenna side, this side of the continent or the side of the world has a definitive lead, and it's not sort of the antenna sticking up out of your car. This is super high tech, high value technology, correct?
Yeah, I mean, it is, period. I don't know of any. There are a couple of, there's one Japanese supplier who's actually quite good at this, but other than that, I don't know a lot of Asian suppliers. And I would say, frankly speaking, the reason this took such a long time for Peraso is the real challenge here is finding, the substrate technology that actually gives you the performance necessary, but at the same time is manufacturable in high volume. So for example, you could find a substrate that gives you great performance and you can't build them. Like, you just can't build them, right? Like, we went through that, and it's kind of interesting process, and we went through that, and it took us a while to really kind of nail down, find that balance between, performance but something we could build at millions of units a year.
All right.
But on that note, I will point something out that's actually critical, and this will be a good segue into the rest of the presentation, though. But for 5G, if you recall, I mentioned we cover, the 28 and 39 gig bands. Realistically, it's from 24 gigahertz to 43 gigahertz. And our antenna team actually managed to build an antenna that covers that entire range. That really is groundbreaking, and of course what we patented. So we really feel that in in the 5G market, it's, besides the fact that we've got very strong RF technology, our antenna technology is very unique as well.
Thank you.
So now getting on to some of the specific applications, I'll start off with 5G fixed wireless access, and so that's basically broadband. This is just providing providing internet access to the masses, right? And you've seen a lot of press now in the States, for example, $65 billion fund to roll out broadband, wireless broadband, or just high-speed internet access to everybody in the States. One of the best ways to do that is fixed wireless access. So, Peraso has that covered. So we really are one of the leaders, if not the leader worldwide in that marketplace. And I'll get into some detail on that. So we're doing that today, and we're doing that in the future with our 5G technology. And then consumer electronics. So be it, metaverse, laptops, tablets. Eventually, we do see going into mobile, because we think mobile is just another aspect of consumer electronics. But so the two, so I think to summarize it, Martin, the two broad categories are kind of outdoor, call it enterprise industrial, big iron technology, and then indoor, more consumer electronics, lower cost, higher volume applications, if you will.
Okay.
So those are the two broad categories for us. Today, we are shipping into some, major OEMs. So, basically, the people really providing the value in this market are what are called wireless ISPs. So these are internet service providers who use wireless to provide internet service. So we ship into that market. For example, that's the customer that we see having the 29 or 30 kilometer link. But as it turns out, I mean, that's an important, you had mentioned earlier, for point to point, that's an important metric. But actually, Peraso also is a very strong player in point to multipoint. And we actually support 32 endpoints. So for example, the wireless service providers can actually support with one access point 32 customers. So that as opposed to having one access point for each customer, now we can divide that by 32 endpoints. And so that's become a very, very powerful weapon for us in the wireless service provider market. So we feel actually in existing millimeter wave market, we are the leader on a global basis in that business.
So crudely, a use case for that would be, let's say you're providing broadband to a suburb subdivision. The AT&T or whoever has the point-to-point fixed wireless, they could have one antenna and put a receiving antenna on 32 homes, and they could provide 32 homes broadband access with that.
Exactly, and each home would get 100 megabits symmetrical, so that's pretty darn good coverage, if you will, right? So and then obviously if they put a second access point, then you can get even more, but 30, but that's exactly what we're doing now.
Okay.
Yeah.
Well, yeah, it's still shocking how many suburbs or small towns have horrible or even dial-up internet access. It's not ubiquitous yet.
It really isn't. And I know I'm in Toronto. It doesn't take long to get out of Toronto before you have poor internet service. It's actually shocking. So needless to say, there's a very good market for this globally. It's obviously in the millions, right? So that's a really nice business for us, and it's growing. And then we expect to, so that's actually with our existing products, and we expect to carry all of that momentum into the 5G. So our first product in 5G will be fixed wireless, and we haven't actually announced it yet. But when we announce it, the key aspect to our 5G product will be the fact that it supports both bands in 5G, the 28 and 39 gig band. And so that's a very special trick for us. So that's really our beachhead, you would say, is fixed wireless, but we expect to really expand that architecture, if you will, to more high volume opportunities like laptops, and ultimately look at mobile.
So when you say 5G fixed access, that's not in my phone, that would be on like a laptop or a PC, something that's not sort of mobile, like, so to speak, it's fairly fixed, or if it's a point to a building where you get that fixed wireless? Well,
today what it would be is a gateway device. So it would be a gateway device that sits in your house or on your wall.
Yeah.
And it's just got a direct link to your cell tower. So that's the first. And we really expect to provide gigabit links for carriers using that technology. So that's because we have been so successful with our existing products, we
Yeah.
really see taking that capability into the 5G space, and that's that's our 5G initiative. But the beauty of the strategy is that because it targets endpoints and targets both frequencies, and our antenna technology covers both bands, we can expand that and scale that to higher volume opportunities in 5G.
Okay. On your prior slide, that technically wasn't 5G. It's other high bandwidth wireless, but not technically 5G.
It's 60 gigahertz. It's still millimeter. They're both millimeter wave.
Okay, but it's not part of the 5G framework or whatever
No.
you call it.
No.
Okay.
No. So then in consumer electronics, the idea, so I would generally care. So in our fixed wireless, I think we've got we have a strong business today, and we see that moving into the 5G space. The other neat aspect of millimeter wave, Martin, is that it's obviously very high data rate and very low latency. So this really facilitates things like high-speed video. And so that could be docking stations. We've actually got an opportunity with a very large customer in video conferencing. They want to make all of their USB cameras wireless, which is a great application. And of course, AR/VR, because AR/VR is video, and it's high performance video, and it requires very low latency. So these are the broad category of applications we're going for with our millimeter wave technology with our existing products and ultimately into 5G.
All right.
I'll just speak one slide to the metaverse, and this is actually quite interesting. So we've actually got two very large customers we're going through trials with right now, and so the use case in the metaverse, if you will, is clearly with VR headsets, it's important to be wireless. I mean, having a cable doesn't make any sense. But solving that problem is very, very tricky. And you actually touched on it earlier, which was the beam tracking. And you can imagine if someone's playing a video game, a war game, his head is moving like crazy. So it's actually a very tough problem to solve, to make sure you never lose that link, and you do it with low latency, under 5 milliseconds. So we've actually solved that problem. So we're actually using this to go after some of these metaverse applications, but it's definitely another category that we think we can ultimately be successful in. For sure, the fixed wireless is the beachhead, but we see some of these internal applications like video conferencing or the metaverse as a place we can go on consumer electronics.
I assumed with the AR/VR that would be based on like some Wi-Fi technology. Is Wi-Fi like a competitive type technology for you, or does it sort of augment you, or what are sort of the benefits you have over Wi-Fi, or how do you differentiate each other from those?
So we have higher performance than Wi-Fi. So the reason that the one primary benefit that we have over Wi-Fi is latency. And this goes back to the whole 5G is like, how do you get low latency? Well, you get it with millimeter wave. And so latency, I'm sure you've used a Wi-Fi or a VR headset. If there's any latency, it kind of makes you sick, right? So you really, really have to solve the latency problem. And Wi-Fi's got a real problem with that. The other problem with Wi-Fi is actually they use a very wide band, and there's so many devices that use the same band. You'll frequency experience interruptions, which again, for a VR experience just doesn't work. Whereas with our beam, it's basically, it's interference free. So you get, so really the two advantages of we win on latency and we win on interference management.
I'm not sure if you addressed this in future slides, but one of the talking points on 5G was in like surgery, automated surgery systems, or factory automation. And that's, I guess, where you're coming down to low latency. You can't afford to have any low latency if you're doing a robotic heart surgery or whatever, and you're
that's pretty valid. You wouldn't want to make a mistake during surgery, right? So actually, so we don't have a specific example on surgery, but we actually have a customer going in production on factory automation. So for example, there you need to avoid latency on those situations as well. So if you have an accident, and you have a computer monitor, like a video monitoring system, it has to shut down immediately if your line, there's a problem with the line, for example. Again, security comes into play. You don't want people eavesdropping on your remote factories or your automated factories. So we will be in production this year with a customer doing factory automation using MMWave. So yeah, that's for us a more apt application. The surgery, just haven't come across it yet, but I assume someday that will happen, but we haven't seen it ourselves.
Okay. I've always wondered, I don't know, why not just use Wi-Fi for factory automation, but the latency and security and that now that makes sense.
Yeah, no, it's quite, yeah, that's why we for us too. I mean, for example, a lot of our inbound calls are from exactly that, factory automation. And these are large companies. These are not small companies. And we've got, well, for example, yeah, in Asia, we've got a very, very large customer doing, blanketing all of their transportation hubs with our chips because of the security.
Interesting. Okay.
So I think that might be it from we have, so we should really speak to, I'm sorry, we should also speak to, because we merged with Moses back in December. Moses was a very, very strong company with regards to high-speed memory. So by the way, I'm going to move on from MMWave, Martin. I don't know if you have any more questions or.
No, I think that did it. My brain's pretty full with all this new.
I think you did
MMWave knowledge I packed in there. So thanks.
For the memory products, the business was primarily providing very high-speed memory, primarily to FPGAs in data center type applications. So packet processing.
Can you just tell people what FPGAs are?
Oh, sorry, field programmable
gate array.
Gate array. So what that basically means is that it's a device that you can change the circuit arrangement on the fly in the field. So these devices, let's say they're doing, so I mentioned the term packet processing. So basically, if you've got a data stream coming off the internet and you need to, let's say, classify those packets, you want to say, well, this is a video packet, so it needs to go, it needs to get processed immediately, or a voice packet needs to get processed immediately, or it's just a web page, it doesn't need to get, so these packets need to get prioritized. You need to inspect the packets, you need to figure out what to do with them, and you need to do this in very, very low latency real time. And so Moses is very, very good at this. And really, I think a world leader in that technology. And so this business is a very good business, coming in at high margin. And so this is a business that we see moving forward with over the course of the rest of this year.
All right. Are there direct synergies? Like you've got, like, it's all within the same general space of the world of technology, but is there some of the Moses technology that can get integrated with Peraso stuff and vice versa, or is it kind of sort of parallel type? So if you know what I mean.
It's a very good question. I mean, I'd say the closest we've come to it is, our OEMs that really deal with that part of the system. So, I mean, just throw it out. Let's call it a Nokia that actually has wireless technology, and they also have data center technology. So they may look at our products as part of, as solutions for different parts of their system. So there's some synergy there, but I wouldn't, I think technically we haven't found anywhere where there's just a direct overlap or cross-functional benefit, if you will, in terms of the synergies of the products.
Gotcha. So there are operational synergies, and it was a means for you to go public through this type of a transaction. Yeah,
exactly. It was really a win-win. I mean, so we needed a means to go public, and Moses was looking for a partner, and so that was really the motivation for both companies to pull off the transaction.
Yeah, there's definitely operational synergies. Obviously, Moses is a small company. Now we just have the greater scale and size with the combined revenue, and spreading the expense structure. We obviously had the public company infrastructure, have operations resources, some of it. So we've identified operating kind of synergies on that front. as well. But being able to just create more size and scale of a company was another key driver.
Gotcha. All
And
right.
just to be clear on the chip side, really the future R&D efforts are driven towards millimeter wave. The memory chips, are what they are. We have not been developing new memory chips. The good news is that, memory technology can ship for over a decade. There's not a lot of advanced developments in memory technology other than on the DRAM front, which is very slow technology versus ours that's very high speed, low latency. But our primary engineering focus going forward for the company is obviously the large millimeter wave 5G opportunity.
Okay, so this is a bit of a sort of a cash cow that you get to kind of milk over the next years, and it's established technology that
Yeah, 60% gross margin business, tier one customers, and actually we're up through the reported numbers through the 9 months. It had done about $4 million in revenue. We actually, based on backlog, expect an up year, so it'll be a positive contribution margin from the business.
Perfect. Okay, thank you.
Great. So now we move on. We've got a couple of financial slides, Martin.
Perfect.
That Jim will address.
I'm going to try to move very quickly because I think, Martin, we're up at the noon hour, right?
No,
yeah. I don't have a hard stop. I don't know about you guys, but yeah, let's try to keep it up around an hour. Otherwise,
I see some questions in the Q&A, so I do.
I was one of those COs that just ran on and on, Martin. Is that the?
No, I think it was pretty meaty what we all went through.
Okay,
so,
great.
That was good, and I enjoyed it. Thank you.
Thank you.
Okay, so this slide here is the present. This is our income statement and non-GAAP reconciliation from our earnings release, which we put out a couple of weeks ago for the fourth quarter and year ended December 31, 2021. To be clear, these are the historical financial statements of Peraso Technologies Inc., the private company focused on millimeter wave 5G technology. Peraso Technologies merged with MoSys. These only include the results of MoSys, the historical public company, for the 2-week period commencing December 17th, 2021. So the income statement is primarily Peraso Tech. The balance sheet, which is on the next slide, is the combined company. So just want to make that clear. Under GAAP, the private company was the acquirer. The key point of note, we expect significant revenue growth in 2022 from the growth in Peraso's business as they began shipping modules in 2021. As Ron highlighted the advantages of that with chips, software, antenna technology, faster time to market, cutting out customer testing, et cetera. Key driver of product growth, throughout 2021. And then, as I said, with their continued growth, as well as the MoSys contribution, will drive that very positively. The other point will be, we'll see improving gross margins. For the fourth quarter, margins were about 30%. We expect to get those well up into the mid 40s going forward as we scale margins. And obviously you start out, it takes time to get scale. So we've identified a plan to improve margins there. Sorry, Martin, I'm just turning back to the balance sheet. I'll keep this very quick here. Through the business combination, the combined company had about $18 million of cash and investments at December 31. Total assets of about $48 million, which obviously includes the cash, as well as approximately $18 million of goodwill and intangibles recognized in the acquisition, and kind of normal, ordinary course, accounts receivable, inventory, et cetera. Liabilities, all ordinary course. The company is debt free. $42 million of strong stockholders' equity from a NASDAQ perspective. On the capitalization, 19.8 million share TSO. There's another 1.8 million escrow shares, which are held by Peraso Tech shareholders, or in escrow for Peraso Tech shareholders, that will be released if the stock hits $8.57 during a certain trading window during a 3-year period. Included also, I should mention, the TSO is about 8 million exchangeable shares held by former Canadian stockholders of Peraso Tech. Those have all the rights of our common stock. Warrants, about 100,000 of those. Options and RSUs held by our employees under our equity plan. So fully diluted, approximately 23.4 million shares outstanding.
And when you say TSO, is that total shares outstanding?
Sorry, yes. Total shares outstanding. Sometimes it's CSO, common stock outstanding.
Okay.
Yes.
Gotcha. And are you giving any sort of, or even sort of ballpark revenue guidance for 2022? Just sort of orders of magnitude, or are you just staying off of that?
You know, with the supply chain challenges, we basically have not been giving guidance other than to say we do expect it to be up. You know, as I said, we'll have the full MMWave contribution from the memory products in 2022. And we see a path to growth based on our backlog, which, you know, we've had customers get orders on the backlog, but, you know, there's just uncertainty with supply chain, particularly in the module business where, yeah, we have most of the hardware in there, but there's some small components that can catch us up. But we expect, you know, when we had done the business combination initial announcement back in September of 2021, we had kind of put a number out there of an $18 to $22 million range. We haven't reaffirmed it yet. We haven't backed off it either.
Okay. And
2022.
Yeah, and could you just, obviously, the supply chain issues, there's tons of that, especially in the semiconductor space. Can you just, you mentioned sometimes hard to get your little third-party modules onto your systems, I guess supply chain issues with that. Are you having problems with your foundries or your board or module makers, and just sort of flesh out the supply chain issues you're
I guess I'll start and then I'll let Ron kind of comment. On the foundry side, we've been very fortunate. You know, myself coming from the memory side, being with historical MMWave, we've been very fortunate to get our allocation from TSMC and have made it clear to our customers, get your orders on the backlog. You know, whoever's on the backlog has priority. I think we've shifted into more of a challenge on the substrate front where we're having to place orders out into 2023. And I just mentioned on the Peraso side, there are some small components on the modules, which, you know, I mean, we're hearing stories out there of folks being held up over a 5-cent part kind of thing.
Yeah.
That said, there's some pieces there that, you know, we have to get our orders from. Let me flip it to Ron. He can probably explain it better.
Well, I mean, I mean, that's where we're at. I mean, I think I'd say I'm cautiously optimistic right now, but, you know, there's surprises. And I think Jim alluded to, like, from our perspective, it's been interesting. Like, the wafer supplies last year were horrible, like TSMC, for example, but it seems to be under control now. It's still long, but it seems more realistic in terms of getting those wafers. But the packaging and test is where there seems to be a bottleneck now. Probably the war isn't helping, I would say, but I don't know. It feels like we're managing through it, but I guess we're trying to avoid surprises right now. As a new company in the market, we really want to make our numbers, and we don't want to, you know. And I think as we start to really, and we'll build up some inventory, frankly, so we'll get more and more secure. But I think we're seeing good orders, and we just want to make sure we can fill those orders. I mean, if there's any, I mean, I say the toughest challenge right now looks to be like the substrate, like the packaging, and even the test a little bit. But yeah, that's where some of the ball. And then of course, you know, this goes to our, I mean, we're seeing this everywhere, it goes to our customers too. I mean, if they can't get a part, they don't need our, you know, so it's really just goes down the chain, right? But
yeah, we saw that quite a bit on the memory side. Our customer had a backlog somewhere else, then their contract manufacturer pushes out, you know, if they're outside the window, can push out the order.
Mm-hmm.
Okay. All right. And what is your current kind of burn rate, or you're not giving revenue estimates precisely yet, like in terms of like route to profitability or anything? Can you make any comments regarding that?
You know, I would just say right now we have a plan to get to profitability with the cash we have now. You know, based on the visibility we see to revenue. You know, certainly going forward, if conditions were right, you know, as a you know, a small cap company in the semi space, you always need to keep an eye on the balance sheet, particularly supplying to tier 1 customers, et cetera. But, you know, in these current, you know, markets right now and the volatility, as Ron mentioned, the war, cash is our biggest asset. So, you know, we're putting in a plan to kind of manage that and manage our growth and get there with what we have.
All right. I just have one final question, then we'll pass it off to the questions in the queue here, and then we can wrap things up close to an hour here. When I think of you guys, I think, wow, you must have some really big monster competitors like the Qualcomms of the world in that. Where do you fit into the whole competitive space? And there's some very big competitors out there. Can you just briefly talk about that?
Well, on 5G, it's a big market. There's a lot of aspects to it, and we feel that we found a market opportunity where we can provide value above Qualcomm, for example, right? And there's I would say for example, we're dealing with a large OEM now that absolutely wants to diversify off Qualcomm. So there's going to be more than one player. It's as simple as
Yeah.
that. And we'll
Okay.
be the other player. I mean, there's just no doubt about it, right? So we, at some level, it's kind of interesting because Qualcomm, obviously, I don't know if it's obvious, but they do millimeter wave, but they're kind of promoting it and getting people used to it and making way for us to come through with our solution. And we've got a very competitive solution, and absolutely every carrier in the world and every OEM in the world wants multiple vendors.
Yeah.
They're not going to rely on Qualcomm for their solution. So we definitely are going to be participating in that market.
Okay. On to the questions from the audience. What is the status of the China Unicom Shenzhen division contract?
Well, the good news there, just for everyone's information, is that we, after 6 months, of intense scrutiny, through rainstorms and snowfall and stuff, they're actually using our chips for backhaul on their 5G network, actually. So went through high scrutiny. We're just standing by. I think they're waiting for internal orders to materialize. So we expect to see revenue from that this year. But yeah, so we think all of the barriers have been removed in order for them to start just placing orders.
Is your technology at all limited or blockaded through the trade restrictions with China and so forth? Are there limited people or certain countries or companies that you're not allowed to sell to?
Well, definitely Huawei. So
yeah,
Huawei is off the list. I believe ZTE. There's also at least two video surveillance companies we're not allowed to deal with. So, but generally, actually, there's a lot of, most companies we can deal with. So, for example, China Unicom is a company we are allowed to deal with. So,
okay.
But there's definitely some that we're not, and I think I've listed the ones that we're not allowed to deal with.
All right. How many carriers are using millimeter wave to enhance their 5G? Right now, I have a 5G phone, but it feels like it is slower than my old 4G. Would adding millimeter wave tech improve 5G speeds? And are you guys working directly with any carriers?
The answer to that question is definitely there's actually not so much in Canada today, but in the US there's definitely 5G capability. But it's, as I mentioned earlier, Martin, we believe where you're going to see that real 5G rollout is in the congested areas. So if you go to the airport, we think most airports will have it covered. Most stadiums will have it covered. The venues where it's been traditionally very, very difficult to get on the network, we think that's how it's going to roll out. So if you're in the US with an iPhone 12 or iPhone 13, you should have millimeter wave. And if you're in a situation, it'll obviously become more and more prevalent as time goes by. In a high capacity situation, you should be able to get millimeter wave, and it will be substantially faster than the existing 4G.
Gotcha. Is there an opportunity for the carrier, their base stations that are on top of buildings or on cell towers, for your technology to be in those towers? Is that one of your?
So we actually, so I think it's really important to clarify. So there's really two kind of aspects to the network. There's the base stations, which is we call infrastructure, and then there's user equipment. We're going after user equipment. Okay. So we haven't really optimized our technology for the base stations because, first of all, it's low volume. There's a dozen guys trying to do the same thing, but we really feel we bring some advantages to the end user component market. So as I say, started off with fixed wireless, but moving into more consumer devices over time.
Gotcha. Okay. And the final questions here, who are your clients and end users? Are you the leader in millimeter wave tech?
Well, so millimeter wave tech is broad. We support a frequency band today at 60 gigahertz. I think if you check, we are undoubtedly the leader in 60 gigahertz fixed wireless and becoming stronger and stronger. I think you'll see in 2022, we will be the by far the dominant player in that space. And so the only thing I would say on that note is our customers are ultra sensitive to confidentiality. I think if you're a real sleuth, you could figure it on the internet, but they just see our technology as a competitive advantage. And we've got some terrific customers that's growing. But I think it's my personal opinion is that we are the dominant player in 60 gigahertz millimeter wave today, and that will get even stronger over 2022.
Okay, and sir, and so one final question, or actually I've got two final questions. That photo you showed earlier of the module with the antenna on it and your silicone, I guess about how big would that be? And roughly is that like a $10 unit? Is that a $100 unit? What's the kind of ballpark? No, I'm not trying to get competitive advantage off you, but just sort of order of magnitude, what's the value of one of those things?
So it's 3 centimeters by 5 centimeters.
Okay.
The first part of the question. So Jim, if we're allowed to give a ballpark price?
Yeah.
Like $50 bucks.
$50.
Yeah.
Okay. Okay. Perfect.
Yeah.
All right. So, and then what I always wrap up these webinars with is what kind of news flow should we be expecting from you for the next 6-9 months to the remainder of the year? Call it like new product launches, are you going to make client wins, but it's just with an anonymous device maker, or what types of news can we be expecting?
Well, that's a good question. We definitely, so we've really got several categories. First of all, our earnings, quarterly earnings, that's a given, but we will have on I would say probably on a monthly basis, product releases, new features, new products, product related announcements. And then at the same rate, I would say customer related announcements. Again, the customer thing is always tricky because they just find it typically very, very strategic actually. But, we're working, and obviously in some cases when a customer is in full production, it's very easy to find out anyway, but it's interesting how sensitive people are to it. But we will be making some customer related announcements over the next 9 months. Well, on an ongoing basis, frankly.
Yeah.
But really, I would say it's a combination of customer announcements, partnership announcements, which is important as well, right? Yeah. So, for example, in VR, we may do a customer or a partnership announcement, product announcements, and obviously financial announcements. So really those 4 categories on a regular basis, on an ongoing basis. Okay.
Gentlemen, Ron and Jim, thanks so much for taking the time to get into the nitty gritty. And I think the length was more determined by all my questions as opposed to how they were answered. I thought you were very precise and sort of succinct in how you answered some of my vague questions there. So guys, thanks a lot. Have a great day. And I'd love to chat with you in a few months and see how business is developing and progressing along here. So have a great day and talk soon.
Thank you very much.
Thank you. Appreciate it.
Bye-bye.